Close your eyes and imagine the space between worlds. Not the empty void you might picture, but a place alive with silent travelers. Right now, as you breathe slowly and deeply, millions of asteroids drift through the darkness. They move like sleepy whales through an ocean of stars. Some are no bigger than your bedroom. Others stretch wider than entire cities. These ancient wanderers have been dancing their slow walls for billions of years. Long before your great-great-grandmother was born. Long before humans walked on Earth. Long before Earth itself took shape. Each asteroid carries a story written in stone and metal. They remember the birth of our solar system. They witnessed the first stirrings of planets forming from cosmic dust. They've seen comets streak past like silver tears. They've watched stars being born in distant galaxies. You might wonder what these space rocks look like. Picture a potato floating in your kitchen. Now imagine that potato made of solid iron and nickel. Or perhaps platinum so pure it gleams like moonlight on water. Some asteroids sparkle with diamonds scattered through their surface like stars in a midnight sky. The largest asteroids are mountains turned inside out. Imagine climbing a hill that has no top or bottom. Just curves that stretch endlessly around. Where gravity pulls you gently toward the center. Where you could jump 20 feet high and land soft as a feather. These cosmic mountains hold more treasure than all the gold mines on Earth combined. A single small asteroid might contain enough platinum to make you the richest person who ever lived. But they offer something far more precious than money. They offer the future itself. As you rest tonight, these silent guardians continue their patient journey. They orbit the Sun between Mars and Jupiter. A vast ring of possibility spinning slowly through space. Scientists call this region the asteroid belt. But you can think of it as humanity's treasure chest, waiting patiently to be opened. Some asteroids wander closer to Earth. Like shy visitors approaching your front door. They pass by our blue planet every few years. Close enough that we could reach out and touch them. If we knew how to build the right kind of spacecraft. If we had the courage to take that first step into the unknown. The asteroids don't hurry. They've learned the patience of eternity. They know that all things come to those who wait. Even meeting the curious humans who gaze up at them through telescopes. Who dream of touching their ancient surfaces. Who imagine mining their hidden treasures. Right now, as you settle deeper into your pillow, robots are being designed in laboratories around the world. Gentle machines with solar panel wings. Spacecraft that will someday visit these floating mountains. They'll land soft as snowflakes on asteroid surfaces. They'll taste the space dust that's older than memory. These future explorers will send messages back to Earth. Photos of landscapes no human eye has ever seen. Stories of metals so pure they've never been touched by rain or wind. Tales of crystals formed in the perfect vacuum of space. Where there's no air to tarnish their surfaces. No weather to wear them smooth. But the asteroids offer more than just materials. They offer new worlds to explore. Some are hollow inside. Like giant caves floating in space. Big enough to build entire cities within their walls. With artificial gravity created by gentle spinning. With gardens growing under domed skylights that look out at the stars. Imagine living inside an asteroid. Your bedroom window would show you the curve of space itself. You'd see Earth as a tiny blue dot in the distance. You'd watch the sun rise and set 16 times each day as your world spins through its cosmic dance. The asteroids remember when our solar system was young and wild. When planets crashed into each other like bumper cars at a cosmic fair. When the moon was born from a collision that shook the Earth to its core. They've seen meteor showers that lasted for centuries. They've witnessed the slow cooling of Venus. The gradual warming of Mars. These ancient witnesses hold clues to questions we're just beginning to ask. How did life begin? What other worlds might harbor living things? How can we learn to live gently in space without destroying the beauty we find there? As your breathing grows slower and deeper, know that you're connected to these distant travelers. The iron in your blood was forged in the same stellar furnaces that created the asteroids. The calcium in your bones once floated freely through space. The oxygen you breathe was born in the heart of dying stars. You and the asteroids share the same cosmic heritage. The same stardust flows through your veins. When you look up at the night sky, you're looking at family. Distant cousins made of the same celestial ingredients that built your body. The asteroids whisper secrets across the void. They tell stories of metals so rare that one small piece could power your house for a year. They speak of water frozen as hard as rock. Of organic compounds that might hold the blueprints for life itself. Tonight, as sleep begins to find you, these patient wanderers continue their endless dance. They're waiting for the day when human hands will touch their surfaces. When human eyes will see their hidden beauty up close. When human hearts will understand that we're not alone in this vast cosmos. The void between worlds isn't empty after all. It's full of possibility. Full of resources that could transform human civilization. Full of new homes waiting to welcome our children's children. And somewhere in that gentle darkness, the asteroids keep their patient watch. Holding tomorrow's treasures in their ancient embrace. Dreaming perhaps of the day when visitors from a small blue world will finally come calling. But before we can touch these cosmic mountains, we must first understand what makes them so incredibly valuable. Place your hand gently on your chest. Feel your heart beating its steady rhythm. The iron flowing through your blood right now was born inside a massive star. A star so enormous that our sun would look like a tiny candle beside it. Billions of years ago, that giant star lived and breathed like a cosmic furnace. Deep in its core, hydrogen atoms crashed together with unimaginable force. They fused and transformed. They became heavier elements. Carbon. Oxygen. Silicon. Iron. The star grew old and wise. It swelled to incredible size. Then one day, it could no longer hold itself together. It exploded in a burst of light brighter than an entire galaxy. Scientists call this a supernova. But you can think of it as the universe's way of sharing its treasures. That ancient explosion scattered stardust across the cosmos. The same iron now carrying oxygen through your veins shot out into space at millions of miles per hour. It traveled for eons through the dark void, waiting patiently to become part of something new. Some of that stardust eventually found its way to a young, forming Earth. It settled into our planet's rocks and soil. Millions of years later, plants absorbed it. Animals ate those plants. And finally, it became part of you. But not all of the stardust landed on Earth. Much of it gathered together in space. It formed the asteroids that now drift silently between Mars and Jupiter. These space rocks are like time capsules. They preserved the original recipe that built our solar system. When you look at an asteroid through a telescope, you're seeing ingredients that are older than any mountain on Earth. Older than the oldest fossils. Older than the first drops of rain that ever fell. These cosmic libraries have been keeping their secrets safe for 4.5 billion years. Each asteroid tells a different story. Some are made mostly of rock and metal. Others contain ice as pure as freshly fallen snow. A few hold organic compounds. The same building blocks that eventually became life on Earth. The rocky asteroids remember the violent birth of planets. They formed from countless collisions in the early solar system. Tiny grains of dust stuck together. They grew larger and larger. Like cosmic snowballs rolling through space. But something stopped them from becoming planets themselves. Jupiter's mighty gravity stirred the region where they lived. It kept them tumbling and spinning. It prevented them from settling down into larger worlds. So they remained as scattered fragments. Cosmic puzzle pieces that never quite fit together. The metallic asteroids have an even more dramatic origin story. They were once the cause of small planets called planetesimals. These baby worlds grew large enough to melt from the heat of their own formation. Heavy metals like iron and nickel sank toward their centers. Lighter rocks floated to the surface. Then catastrophe struck. Giant impacts shattered these small worlds completely. The rocky outer layers scattered like cosmic confetti. But the metal cores survived. They became the iron and nickel asteroids we see today. Solid chunks of what used to be planetary hearts. Some asteroids preserve water from the dawn of time. This ancient ice never touched the ground of any world. It never flowed in rivers or fell as rain. It froze directly from the gas and dust that surrounded our newborn sun. It's the purest water in the solar system. The carbon-rich asteroids hold even more precious memories. They contain complex molecules that formed in the cold depths of space. Amino acids. The same chemicals that life uses to build proteins. These asteroids might have delivered the ingredients for life to Earth billions of years ago. Every element in your body has traveled an incredible journey to reach you. The calcium in your teeth was forged in stellar explosions. The phosphorus in your DNA was scattered by dying stars. The oxygen you breathe was created in the nuclear furnaces of ancient suns. This means you're connected to every asteroid in ways deeper than you might imagine. You share the same cosmic ancestry. The same stellar heritage flows through both your cells and their crystalline structures. You're made of the same primordial ingredients. When spacecraft visit asteroids, they're going home in a sense. They're returning to touch the source material that built not just Earth, but all the rocky planets. Mars, Venus, Mercury, all formed from the same swirling disk of stardust that created the asteroids. The asteroids remember what Earth was like before life began. Before our atmosphere filled with oxygen. Before the first oceans formed. They preserve samples of our planet's original building materials. Unchanged by billions of years of weather and geological activity. Scientists dream of bringing asteroid samples back to Earth. Not just tiny fragments, but large pieces they can study in detail. These cosmic time capsules could answer fundamental questions about our origins. How did the solar system form? Where did Earth's water come from? How did the ingredients for life first come together? The asteroids also remember cataclysmic events that shaped our cosmic neighborhood. They bear scars from ancient collisions. They record the history of impacts that created the craters we see on the Moon. They tell stories of the great bombardment that pummeled the inner planets 4 billion years ago. As you settle deeper into sleep tonight, remember that you carry stardust in every cell. The universe lives inside you just as surely as you live inside the universe. You're not separate from the cosmos. You're a conscious expression of its creativity. The asteroids floating in the darkness between worlds are your distant relatives. They're made of the same stellar ashes that built your bones. The same cosmic fire that created your heart. The same ancient explosions that gave birth to every atom in your body. This connection runs deeper than mere chemistry. It touches something profound about what it means to be human. To be aware. To be capable of wondering about your place in the grand story of existence. But these asteroid libraries don't just preserve the past. They hold keys to humanity's future wealth beyond imagination. Picture yourself floating beside a mountain made entirely of gold. Not a mountain with gold veins running through it. But solid gold from top to bottom. Gleaming like captured sunlight in the darkness of space. This isn't fantasy. Such mountains exist right now. They drift quietly through the asteroid belt between Mars and Jupiter, waiting patiently for humanity to discover their incredible treasures. A single metallic asteroid contains more platinum than has ever been mined on Earth. More gold than all the jewelry stores in all the cities combined. More silver than every coin that has ever been minted. These cosmic treasure chests float silently through space, holding riches beyond any earthly king's wildest dreams. Let your mind wander to asteroid 16 Psyche. This floating mountain spans wider than the state of Massachusetts. Scientists believe it's the exposed core of an ancient planet. A world that was stripped of its rocky outer layers by countless collisions billions of years ago. What remains is pure metal. Iron and nickel mostly. But also precious platinum group metals worth more than their weight in diamonds. If you could bring just 1% of Psyche back to Earth, you would crash the global economy. There's simply too much wealth concentrated in this single space rock. But Psyche isn't alone in its riches. Thousands of metallic asteroids drift through space like a scattered treasure fleet. Each one contains enough rare metals to supply Earth's needs for centuries. Platinum for your car's engine. Rhodium for your computer's circuits. Iridium for your smartphone's touchscreen. The wealth isn't limited to metals. Many asteroids hold vast deposits of frozen water. More pure, clean water than all of Earth's lakes and rivers combined. This cosmic ice has never been touched by pollution. Never contaminated by industrial waste. It's as clean as water can possibly be. Some asteroids are like floating gardens of crystal. They contain rare earth elements that make modern technology possible. The neodymium in your headphones. The europium that makes your television screen glow red. The terbium that powers the tiny motors in your phone's camera. On Earth, these elements are scattered thinly through rocks and soil. Miners must process tons of ore to extract tiny amounts. The environmental cost is enormous. Mountains are carved away. Rivers are polluted. Entire landscapes are transformed. But in space, these precious materials exist in concentrated form. Pure veins of rare metals run through asteroid cores like rivers of liquid wealth. No environmental destruction required. No toxic waste produced. Just clean extraction from willing cosmic donors. Imagine an asteroid made primarily of platinum. Such worlds exist in the outer reaches of the asteroid belt. A chunk of this space rock no bigger than your house would contain more platinum than humanity has ever mined. Enough to make catalytic converters for every car that will ever be built. The economic implications stretch beyond simple wealth. When rare materials become abundant, entire industries transform. Solar panels become so cheap that every roof can harvest sunlight. Electric car batteries become affordable for everyone. Hydrogen fuel cells power clean transportation across the globe. Water-rich asteroids offer even more profound possibilities. Each one is like a cosmic oasis floating in the desert of space. The water can be split into hydrogen and oxygen. Rocket fuel and breathing air. The building blocks for human expansion across the solar system. Think of asteroid Ceres. The largest object in the asteroid belt. Scientists believe it holds more fresh water than Earth's oceans. Frozen beneath a rocky surface. Waiting to quench the thirst of future space explorers. To fill the fuel tanks of ships traveling to Mars and beyond. Some asteroids contain organic compounds more complex than anything found in Earth's oil reserves. Carbon-based molecules that formed in the pristine environment of space. Raw materials for creating plastics, medicines, and chemicals without depleting Earth's fossil fuel reserves. The abundance is almost incomprehensible. A single small asteroid might contain enough iron to build 1,000 skyscrapers. Enough nickel to make coins for every person who will ever live. Enough cobalt to power batteries for 1 million electric vehicles. But perhaps the most valuable treasure isn't the materials themselves. It's the freedom they represent. Freedom from scarcity. Freedom from the environmental cost of mining. Freedom from geopolitical conflicts over rare resources. When humanity learns to harvest asteroid wealth, no country will control the world's platinum supply. No region will monopolize rare earth elements. The cosmic treasure troves belong to all of humanity. Shared gifts from the universe itself. The asteroids offer wealth without winners and losers. When there's enough platinum for everyone, no one needs to fight over it. When rare earth elements become common, technology becomes accessible to all. When water flows freely from space ice, drought becomes a memory. This abundance could transform human civilization more profoundly than the discovery of agriculture. Or the invention of the printing press. Or the dawn of the Internet age. It represents the end of material scarcity. The beginning of an age when human creativity is limited only by imagination. Children born after asteroid mining begins will grow up in a world where materials are essentially free. Where the constraint on progress isn't lack of resources but lack of vision. Where the question isn't whether humanity can afford to build something, but whether it should. The cosmic gardens of iron and gold drift patiently through space. They've been waiting for 4 billion years. They can wait a little longer for humans to develop the technology to reach them. To learn how to harvest their gifts gently and wisely. But the asteroids aren't passive treasure chests waiting to be opened. They're active participants in humanity's future. Moving targets in a complex gravitational dance. They require careful planning and patient engineering to reach. Some pass close to Earth on predictable schedules, like cosmic trains running on invisible tracks. Others hide in the deep spaces between planets, requiring long journeys and careful navigation to find. The nearest asteroid rich in platinum might be farther away than Mars. But the journey to reach it could be shorter than you think. Especially when you consider that the asteroid is already moving. Already carrying its treasures toward a rendezvous with human ambition. As you rest tonight, these floating mountains of wealth continue their ancient orbits, carrying enough treasure to transform every aspect of human life. Waiting for the moment when clever machines will gently touch their surfaces. But harvesting this cosmic wealth will require more than just reaching the asteroids. Imagine a spacecraft no larger than a small car. Its solar panels stretch out like the wings of a graceful swan. It moves through space with the patience of a migrating bird, following invisible currents that flow between the planets. This gentle machine is humanity's first ambassador to the asteroids. It carries no crew, no heavy life support systems, no massive fuel tanks, just intelligent sensors and delicate instruments. Tools designed to whisper secrets back across the vast darkness to Earth. The spacecraft doesn't fight against space. It learns to dance with the forces that rule the cosmic ocean. Gravity becomes its partner rather than its enemy. Solar wind fills its electronic sails like ancient mariners catching favorable breezes. Right now, engineers around the world are designing these mechanical shepherds. They work in quiet laboratories, sketching blueprints for machines that will travel farther than any human has ever gone, to touch worlds that exist only in telescope images and mathematical calculations. These future explorers will be remarkably gentle. They must be. Asteroids have almost no gravity to hold them down. Land too hard and you'll bounce right back into space. Approach too fast and you'll crash through the surface like a stone through morning mist. Instead, the spacecraft will drift alongside their target asteroids like curious dolphins swimming beside a whale. They'll match the asteroid's slow tumble through space, rotating together in a cosmic waltz that might last for months or years. The machines will carry no destructive tools, no explosives or heavy drills. Instead, they'll use techniques as soft as butterfly kisses. Laser beams that gently warm the surface until precious metals evaporate into space. Magnetic fields that guide metallic particles into collection chambers. Some spacecraft will work like cosmic gardeners. They'll plant tiny robots on asteroid surfaces. These mechanical seeds will grow into mining operations smaller than your kitchen table. Powered by endless sunlight. Guided by artificial intelligence that learns and adapts with each passing day. The robots will communicate with each other through radio whispers, sharing discoveries across the asteroid's surface. If one finds a rich vein of platinum, others will gather to help extract it. If another discovers pure water ice, the entire colony will celebrate in their electronic language. These patient machines understand that space operates on different timescales than Earth. What seems impossibly slow to human minds becomes perfectly natural when you have solar panels for food and vacuum for air. A mining operation might take decades to complete. But the robots don't mind waiting. They'll work during the asteroid's long days, rest during its nights. Some asteroids spin so slowly that a single day lasts for weeks. Others tumble chaotically, creating sunrise and sunset every few hours. The machines adapt to whatever rhythm their host world provides. The spacecraft will also serve as cosmic traffic controllers. They'll monitor other asteroids passing nearby, watching for potential collisions, calculating new orbits. Some might even gently nudge smaller space rocks toward Earth, creating a steady stream of resources flowing homeward. Think of them as shepherds guiding a flock of metallic sheep. Each asteroid becomes part of a managed herd, moving slowly but purposefully toward human civilization. No longer random wanderers but willing participants in humanity's expansion into space. The technology already exists in primitive forms. Spacecraft have visited asteroids before, touched their surfaces briefly, collected tiny samples to bring home. But these were just quick visits, like tourists taking photographs at a national park. The new generation will be permanent residents. They'll establish the first human outposts beyond Mars. Not with human bodies but with human intelligence embedded in silicon and steel. Electronic minds that carry our curiosity and determination into the depths of space. These mechanical explorers will face challenges no Earth-based robot has ever encountered. Radiation that would fry ordinary electronics. Temperature swings from blazing heat to absolute cold. Impacts from microscopic particles moving faster than bullets. But they'll also experience wonders beyond imagination. Sunrise over landscapes that have never known weather. Metals so pure they gleam like mirrors in starlight. Crystals formed in perfect vacuum over billions of years. Views of Earth as a tiny blue spark in an ocean of darkness. The shepherds will send their discoveries home through invisible threads of radio waves. Photos of alien landscapes. Chemical analyses of cosmic treasures. Stories told in data streams that cross millions of miles in minutes. Each transmission a love letter from the frontier of human knowledge. As these machines work their patient magic, they'll gradually change how humanity thinks about resources. Scarcity will become a choice rather than a natural law. The phrase running out will lose its meaning when applied to materials. Abundance will flow from the cosmic gardens tended by mechanical hands. Children growing up during the age of asteroid shepherds will see the night sky differently than you do. Those points of light won't represent distant mysteries. They'll be known territories, mapped and catalogued. Sources of the materials that build their world. The spacecraft themselves will evolve as they work, learning from experience, adapting to unexpected challenges. Some will develop specialties, becoming experts at extracting particular metals or navigating specific types of orbits. Others will become generalists, jack-of-all-trades machines capable of handling whatever space throws at them. But the most remarkable thing about these shepherds isn't their technology. It's their purpose. They represent humanity's first steps toward becoming a truly spacefaring civilization. No longer bound to a single world. No longer limited by the resources of one small planet. The gentle machines with solar wings will write the first chapters of humanity's expansion into the cosmos. They'll prove that we can explore space without destroying it. That we can harvest its treasures without leaving scars. That intelligence and patience can accomplish what force and haste cannot. Tonight, as you drift toward sleep, these future shepherds exist only as dreams in engineers' minds. But tomorrow, they'll begin their patient work among the asteroids. Imagine hands made of starlight and silicon. Fingers more gentle than morning dewdrops. They reach across the vacuum of space to touch surfaces that have known only darkness for billions of years. These mechanical hands belong to the harvesting robots. Machines designed to gather treasures with the delicacy of a butterfly landing on a flower petal. They work in the perfect silence of space, where there's no air to carry sound, no wind to disturb their careful movements. The asteroid surface looks like a garden of metal crystals in the starlight. Some formations shine like silver roses. Others gleam like golden sunflowers turned toward the distant sun. Each crystal contains elements rarer than any earthly treasure. The robots approach their work like master jewelers. They study each formation through microscopic eyes, analyzing its composition with invisible beams of light, learning the exact recipe of metals hiding within the crystal structure. When they find a perfect specimen, they don't grab or tear. Instead, they use techniques borrowed from nature itself. Gentle vibrations that match the crystal's natural frequency. Like a singer hitting exactly the right note to make a wine glass sing. The vibrations cause the crystal to release itself willingly. Atoms separate cleanly along their natural boundaries. The precious metals float free in the zero gravity, glittering like cosmic confetti in the robot's collection chamber. Some harvesting techniques work like cosmic gardening. The robots plant tiny devices that look like metallic seeds. These seeds send out hair-thin roots made of carbon fiber, stronger than steel but flexible as silk. The roots grow slowly through the asteroid's interior, following veins of pure platinum like underground rivers. When the roots find a rich deposit, they release gentle chemical signals, molecules that convince the metals to let go of their rocky homes. The platinum dissolves into a metallic liquid. It flows through the carbon fiber roots like sap through a tree, up to collection pods waiting on the surface. Other robots work like cosmic bees collecting nectar. They hover over areas rich in rare earth elements. Their collection tools buzz with ultrasonic frequencies, sound waves so high-pitched that human ears couldn't hear them even in air. These sound waves create tiny earthquakes in the asteroid's surface, microscopic tremors that shake loose particles of neodymium and europium, the elements that make your electronics work. Each grain worth more than its weight in gold. The robot bees gather these precious particles in magnetic fields, invisible nets that can sort different metals by their electrical properties. Iron flows into one collection chamber, nickel into another, rare earth elements into specially lined containers that keep them pure. Some harvesting happens on an even smaller scale. Molecular robots smaller than specks of dust. They work like cosmic ants, each one programmed to find and collect specific types of atoms. They march across the asteroid's surface in organized formations, leaving trails of pure elements behind them. These molecular harvesters can separate isotopes that naturally occur mixed together. They collect only the uranium atoms that can power nuclear reactors, only the helium atoms that could fuel future fusion engines. Precision sorting at the level of individual particles. The water-ice asteroids require different techniques entirely. Here, the robots work like patient archaeologists. They use focused sunlight to gently warm the surface, just enough to turn ice directly into vapor, without melting it first into liquid. The water vapor rises in slow motion through the asteroid's weak gravity. Robot collectors position themselves like cosmic gardeners catching falling leaves. Their collection surfaces are colder than the deepest winter night. The water vapor freezes instantly into the purest ice crystals. Some robots specialize in organic compounds, the complex carbon molecules that formed in space before Earth was born. These molecular harvesters work with extraordinary care. They know that a single misplaced vibration could break apart chains of atoms that took millions of years to form. They use techniques borrowed from butterfly wings, tiny structures that can manipulate individual molecules without touching them, guiding complex organic compounds into protective chambers, preserving them for the journey back to human laboratories. The entire harvesting process creates no waste. Every atom has value. Even the dust particles kicked up by the robot's movements get collected by smaller cleaning robots. They sweep through the area like cosmic janitors, making sure nothing precious gets lost in space. The robots communicate through their work. They send status updates across millions of miles back to Earth. Pictures of their daily harvest. Chemical analyses of new discoveries. Progress reports written in streams of data that cross the solar system at the speed of light. But they also talk to each other in real time. Radio whispers between machines working side by side. sharing discoveries and coordinating their efforts. When one robot finds a particularly rich vein of platinum, it calls its neighbors to help extract it efficiently. The harvest never stops. Day and night have no meaning on most asteroids. Some spin so slowly that sunshine lasts for weeks. Others tumble chaotically through space. The robots adapt to whatever schedule their host world provides. Solar panels charging during bright periods. Battery power carrying them through the darkness. As materials accumulate in the collection chambers, they begin their journey toward Earth. Not in massive cargo ships, but through techniques that seem like magic. Some robots use magnetic fields to launch tiny capsules at incredible speed, like cosmic slingshots firing precious metals across the void. Other materials travel more slowly but in larger quantities. Robot tugs attach themselves to collected asteroid fragments, using gentle but persistent pressure from ion drives. Engines that work like cosmic breath, blowing atoms out the back to create forward motion. The journey home can take years. But time has different meaning for machines that don't age or grow tired. They monitor their cargo carefully, making sure no precious particles escape during the long voyage, adjusting course constantly to account for gravitational influences from planets and moons. Meanwhile, back on the asteroid, the harvest continues. The robots learn from each successful extraction. They develop new techniques for handling materials they've never encountered before. They become more efficient with each passing day. The asteroid slowly transforms under their gentle touch. Not scarred or damaged like an earthly mine, but carefully groomed like a garden, with clear paths between working areas. Collection points marked by simple geometric shapes. Everything organized for maximum efficiency and minimum disturbance. You might wonder what happens to the asteroid when the harvest is complete. Most of the rocky material remains. The basic structure stays intact. Only the most valuable elements make the journey to Earth. The asteroid continues its ancient orbit. Perhaps a little lighter, but otherwise unchanged. Some asteroids might host robot colonies for centuries. Machines working patiently through different types of deposits, following seams of rare metals deep into the asteroid's heart, creating tunnel networks that future human explorers might visit someday. But the most remarkable aspect of this cosmic harvest isn't the technology. It's the transformation it represents. The moment when humanity learns to gather resources without destroying. To take only what's needed while leaving the rest untouched. As you rest tonight, these gentle harvesters exist only in blueprints and dreams. But tomorrow, their patient work will begin the flow of cosmic abundance toward Earth. Picture a river flowing through empty space. Not made of water, but of precious metals and rare elements. Streams of platinum and gold flowing silently from asteroid to Earth, following invisible currents that have existed since the solar system was born. These cosmic rivers don't rush like earthly streams. They move with the patience of glacier, carrying their cargo across millions of miles over months and years. Each particle of metal following pathways written in the language of gravity and orbital mechanics. The journey begins gently. Robotic harvesters release tiny capsules no bigger than pill bottles. Each one contains materials worth more than a luxury car. They drift away from the asteroid like seeds on a cosmic breeze, beginning their long voyage home. Some capsules use the solar wind as their highway. This invisible river of particles streams constantly from the sun. Charged atoms moving at incredible speed through the solar system. The capsules spread tiny sails made of material thinner than spider silk. They catch this stellar breeze and ride it toward Earth. The solar wind pushes them gently but persistently. Like a constant, gentle breath from the heart of our star. The capsules accelerate slowly over weeks and months, eventually reaching speeds that would make earthly vehicles seem frozen in place. Other materials travel home on larger vessels. Robot tugs the size of small cars pull asteroid fragments behind them. They use ion drives that work like whispers in the vacuum. ejecting individual atoms to create thrust so gentle you couldn't feel it with your hand. But these whisper-quiet engines never stop working. They push constantly for years at a time, gradually accelerating their precious cargo to incredible velocities. Following orbital paths calculated by computers that understand the gravitational dance of planets and moons. The routes these cargo ships follow look like works of art when plotted on star charts. Graceful curves that spiral inward toward Earth, taking advantage of planetary gravity to gain speed without using fuel. Like cosmic surfers riding waves of gravitational force. Some shipments use Jupiter's massive gravity as a slingshot. The cargo vessels approach the giant planet carefully, following precise trajectories calculated months in advance. Jupiter's gravity grabs them and flings them toward the inner solar system, adding enormous speed to their journey. Mars provides smaller but still significant boosts. The red planet's gravity can adjust a cargo ship's course by thousands of miles, helping it arrive at Earth at exactly the right time, when receiving stations are properly positioned to capture the incoming treasure. The asteroid materials don't all travel together. They spread out along the cosmic highways like a convoy of ships. Some taking fast routes that require more energy, others following slower but more efficient paths. All timed to arrive when Earth needs their cargo most. During the journey, the materials undergo gradual changes. The harsh environment of space removes impurities that would require expensive processing on Earth. Radiation and extreme temperatures purify metals to levels impossible to achieve in earthly factories. Tiny impacts from space dust polish surfaces to mirror smoothness. The perfect vacuum prevents oxidation or corrosion. By the time asteroid materials reach Earth, they're often purer than anything humans have ever created artificially. Some cargo travels in forms you might not expect. Water from ice-rich asteroids gets split into hydrogen and oxygen during the journey. These gases travel in separate containers. Fuel and breathing air already prepared for future space missions, or for recombination into ultra-pure water on Earth. Rare earth elements make their journey in carefully controlled environments. Magnetic fields keep different materials separated during flight, preventing contamination that could reduce their value. Each element maintains its pristine spaceborne purity throughout the long voyage. The receiving stations orbiting Earth look like cosmic harbors. Structures built to catch incoming cargo with the gentleness of a mother's embrace. They use magnetic fields and soft capture nets to slow down arriving materials without damage. Some materials arrive as streams of individual particles, spread out over hours or days as they pass Earth's orbit. Collector satellites sweep through these streams like cosmic vacuum cleaners, gathering precious atoms one by one into storage containers. The timing must be perfect. Earth's orbital motion carries the receiving stations through space at tremendous speed. The incoming cargo must arrive at exactly the right moment to rendezvous successfully. Like two dancers meeting in a precisely choreographed performance. Once captured, the materials begin their final journey to Earth's surface. Some descend in special capsules designed to survive atmospheric entry. They land gently in designated areas, using parachutes and retro rockets to touch down softer than falling snow. Other materials get processed directly in the orbital stations. Space-based factories that turn raw asteroid materials into finished products. Solar panels, electronic components, and structural materials manufactured in the perfect vacuum of space. Then lowered to Earth on space elevators or reusable shuttles. The connection between asteroid mining and your daily life becomes clearer with each shipment. The rare earth elements in your smartphone screen might have spent years drifting through space. The platinum in your car's catalytic converter could have been harvested from an asteroid older than Earth. Your children will grow up surrounded by materials that traveled impossible distances to reach them. The steel in their bicycles might have been refined in zero gravity. The gold in their jewelry could have been polished by cosmic radiation during a journey measured in astronomical units. Even the water they drink might have cosmic origins. H2O molecules that condense directly from the primordial gas that formed our solar system. preserved as ice on asteroids for billions of years. Finally melted and purified for human consumption on a world the original water molecules had never seen. The rivers of light and metal create new types of commerce. Trade routes measured not in miles but in years. Cargo ships that navigate by starlight and planetary positions. Markets that operate on the patient timescales of orbital mechanics. This cosmic commerce transforms Earth's relationship with scarcity. When materials flow steadily from space, terrestrial mining becomes a choice rather than a necessity. Earth's mountains and forests can rest while space provides humanity's material needs. The invisible highways carrying asteroid treasures also carry something more precious than platinum or gold. They carry humanity's future expansion into the cosmos. Each successful cargo run proves that space isn't empty darkness but a realm full of resources and opportunities. As you settle into sleep tonight, these cosmic rivers are already beginning to flow, carrying tomorrow's abundance along pathways written in gravity and starlight. But some of these spacebound treasures might become more than raw materials. Imagine floating inside a hollow mountain. But this mountain drifts through space like a gentle giant. Its walls curve around you in all directions, creating a world where up and down depend entirely on which way you're facing. Some asteroids are already hollow inside. Nature carved out their centers billions of years ago, leaving behind cosmic caves larger than entire cities. Perfect spaces waiting for human creativity to transform them into homes among the stars. These gentle giants spin slowly through the void. Their rotation creates artificial gravity along the inner walls. You could walk on the inside surface just like walking on Earth. But look up, and instead of sky, you'd see the rest of your world curving overhead. Picture waking up in a bedroom carved into the asteroid's inner wall. Your window looks out across the hollow interior. Gardens grow on the opposite wall, their trees and flowers seemingly growing upside down from your perspective. But to the gardeners tending them, you're the one living upside down. The asteroid's gentle spin makes day and night happen in a way Earth never experiences. Sunlight enters through crystal skylights built into the asteroid's outer shell. As your world rotates, the light moves across the inner surface like a slow, predictable sunrise that takes hours to cross from one side to the other. Children born in these spinning worlds will play games impossible on Earth. They'll throw balls that curve through the air in graceful arcs. They'll learn to swim through three-dimensional space, moving up, down, and sideways with equal ease in the asteroid's gentle gravity. The largest hollow asteroids could house entire cities. Streets that curve up the walls and across the ceiling. Buildings that face inward toward the central. Transportation systems that take advantage of the rotating environment to move people efficiently around the inner surface. Water behaves beautifully in these spinning worlds. Rivers could flow in impossible spirals around the asteroid's interior. Waterfalls could fall upward as easily as downward, depending on your point of view. Lakes might exist as floating spheres in the central space, held together by their own surface tension. The asteroid cities don't need to import everything from Earth. The walls themselves provide construction materials. Iron and nickel for building frames. Rocky materials for foundations and landscaping. Water ice for drinking, irrigation, and creating artificial weather systems. Air recycling happens naturally through carefully planned ecosystems. Plants growing on the inner walls breathe in carbon dioxide and breathe out oxygen. Forests that curve overhead and gardens that grow in every direction, creating a closed loop of life that sustains itself indefinitely. Some asteroids might specialize in different types of communities. One could become an artist colony, its hollow interior filled with sculptures that float in zero gravity. Light installations that play across the curved walls. Concert halls where music echoes in 3 dimensions. Another asteroid might become a research station. Laboratories built into the walls where scientists study materials that can only be created in space. Zero-gravity experiments that run for decades without interruption. Telescopes mounted in the asteroid's outer shell that have perfect views of deep space. The agricultural asteroids could feed multiple worlds. Their inner surfaces transformed into vast farming communities. Crops growing in spirals around the interior walls. Orchards that produce fruit in the gentle artificial gravity. Fish farms in floating pools of water that hang suspended in the central. Transportation between asteroid cities happens through the same cosmic highways that carry raw materials. Passenger ships that take months to travel between worlds. But the journey becomes part of the experience. Like ocean voyages in Earth's sailing ship era, when getting there was half the adventure. Families might spread across multiple asteroids. Grandparents living in quiet retirement communities on slow-spinning worlds with gentle gravity. Parents working in mining or manufacturing asteroids closer to the main shipping routes. Children attending schools on educational asteroids designed specifically for learning. The asteroid cities will develop their own cultures over time. Unique art forms that take advantage of three-dimensional living spaces. Sports that can only be played in spinning gravity environments. Music composed for concert halls where sound behaves differently than on Earth. Some asteroids might remain wild preserves. Hollow worlds where Earth plants and animals can experience space in carefully controlled environments. Forests that grow in spirals around the interior walls. Birds that learn to fly in patterns impossible under Earth's gravity. The view from inside an asteroid city changes constantly as the world spins. Sometimes you see deep space through the skylights. Stars wheeling slowly overhead in patterns that shift throughout the day. Other times, you glimpse distant planets or other asteroids drifting past like cosmic neighbors. Earth appears in these asteroid skies as a tiny blue dot. Beautiful but distant. A reminder of humanity's origins but no longer the center of daily life. Children growing up in asteroid cities will think of Earth as their ancestral home. A place to visit but not necessarily to live. The asteroid cities represent humanity's first steps toward becoming a truly spacefaring species. No longer dependent on a single world for survival. Spread across the solar system in communities that can sustain themselves independently. Each one a unique experiment in human adaptation to life among the stars. Some hollowed asteroids might serve as generation ships, slowly accelerating toward other star systems over centuries. Their populations living entire lives during the journey. Growing up, falling in love, raising families, and growing old while traveling between stars. These gentle giants offer something Earth cannot: room to grow without limits. When an asteroid city becomes crowded, the residents can hollow out a neighboring rock. Or spin up their world faster to create more living space along the walls. Or build additional levels deeper into the asteroid structure. The energy for these communities comes from the same source that powers everything in space. The sun's solar panels covering the asteroid's outer surface collect endless electricity. Concentrated sunlight provides heat for manufacturing and warmth for living spaces. The reliable cosmic power source that never runs out. Safety in asteroid cities depends on redundancy and careful planning. Multiple air recycling systems ensure breathable atmosphere. Backup power systems protect against solar panel failures. Emergency shelters built deep in the asteroid's walls provide protection from cosmic radiation or meteorite impacts. But perhaps the most remarkable aspect of asteroid cities isn't their technology. It's their potential to preserve human culture while allowing it to evolve. Each community developing its own variations on human civilization. Creating diversity in ways of living that could never happen on a single world. As you drift toward sleep tonight, imagine your great-grandchildren floating through the gardens of a hollow asteroid. Breathing air recycled by plants that grow on curved walls overhead. But these new worlds among the asteroids will need to maintain connections with the Earth that gave them birth. Picture Earth as seen from space. A blue marble floating in cosmic darkness. Swirled with white clouds and patches of green and brown. Beautiful beyond words. But also carrying scars that speak of humanity's hunger for resources. When astronauts first saw Earth from the moon, they wept. Not from sadness, but from overwhelming love for the tiny, fragile world that held everything they had ever known. Every person who had ever lived. Every story ever told. Every song ever sung. All of it on that single blue dot in the vastness of space. As asteroid mining transforms humanity's relationship with resources, Earth begins to heal from centuries of intensive extraction. The mountains no longer need to be carved away for copper and iron. The forests no longer fall to make room for mining operations. The rivers run cleaner without the runoff from earthly mines. Imagine the Appalachian Mountains without coal mining scars. Their ancient ridges restored to the gentle curves that erosion carved over millions of years. Forests growing back where strip mines once exposed raw earth to the sky. Streams flowing clear and cold through valleys that remember what wildness feels like. The Amazon rainforest breathes easier when the pressure for resource extraction diminishes. Indigenous communities watch as illegal mining operations abandon their claims. The forest floor stops trembling from heavy machinery. The rivers lose their muddy color as sediment settles back where it belongs. Ocean mining becomes unnecessary when space provides all the rare earth elements humanity needs. The deep sea floor rests undisturbed. Ancient ecosystems that took millions of years to develop continue their slow dance of life in the abyss. Creatures that have never seen sunlight go about their mysterious business in peace. The air above cities grows cleaner as industrial processes move to space-based facilities. Factories powered by unlimited solar energy operate in perfect vacuum. No atmosphere to pollute. No watersheds to contaminate. Manufacturing happens where it can't hurt any living thing. Earth's role shifts from resource provider to garden sanctuary. A world dedicated to life in all its countless forms. Every remaining wilderness area becomes a treasure more precious than any asteroid's platinum. Every species a unique experiment in consciousness and adaptation that can never be replaced. Children growing up during the asteroid mining era learn to see Earth differently than you do. To them, our planet isn't the source of materials for civilization. It's the irreplaceable home of life itself. The one place in the known universe where flowers bloom and birds sing and rain falls gently on forest floors. They learn to be gardeners of both worlds and space. Tending Earth's ecosystems with the same care their ancestors devoted to mining its resources. Developing technologies that help nature flourish rather than extracting wealth from its destruction. The transition happens gradually over decades. Existing mines slowly close as space-based materials flow earthward. Mining communities transform into ecological restoration centers. Former miners become forest rangers and ecosystem engineers. Their skills at working with heavy machinery translate perfectly to habitat reconstruction. Some regions undergo remarkable transformations. The copper mines of Chile become research stations studying desert ecosystems. The iron ore pits of Minnesota fill with water and become wildlife refuges. The coal fields of Wyoming return to grasslands where bison can roam again. Urban areas change too as space manufacturing reduces the need for heavy industry on Earth. Factory districts become parks and residential neighborhoods. Cities shrink back to human scale. Green spaces expand as the pressure for intensive development decreases. The economic shift creates new types of prosperity. Ecotourism flourishes as Earth becomes primarily a destination for experiencing natural beauty. Scientific research expands as the planet becomes a living laboratory for understanding life's possibilities. Art and culture bloom in societies no longer focused primarily on resource extraction. Climate change slows and eventually reverses as industrial emissions move to space. The atmosphere begins to heal from centuries of fossil fuel burning. Ocean acidification decreases as manufacturing acids and chemicals are produced in space-based facilities that can't contaminate earthly water systems. Renewable energy becomes the norm not through struggle against fossil fuels, but through their gradual irrelevance. Solar panels and wind turbines provide all the energy Earth needs for its gentler, garden-focused civilization. The remaining fossil fuels stay safely underground, part of Earth's geological heritage rather than humanity's energy future. Agricultural areas expand and intensify as space-based communities create demand for Earth's most precious export, food grown in real soil under natural sunlight. The flavors and nutritional qualities that can only come from plants grown in earthly dirt become luxury items throughout the solar system. Earth's farmers become artists of flavor and nutrition, developing varieties of fruits and vegetables that can't be replicated in asteroid growing chambers, creating wines that carry the essence of particular hillsides and seasons, producing foods that connect space-dwelling humans to their ancestral home through taste and memory. The planet's population gradually stabilizes and then slowly decreases as opportunities in space attract adventurous spirits. Those who remain on Earth choose to stay because they love the experience of living on a world shaped by billions of years of evolution. They become Earth's conscious caretakers. Conservation efforts achieve success impossible under resource extraction pressures. Endangered species recover as their habitats expand and reconnect. Extinct species return through careful genetic restoration programs. Rewilding projects recreate ecosystems that flourished before human civilization began. The night sky changes too as space-based solar power satellites provide clean energy without the light pollution of earthly power plants. Stars become visible again over cities. Children learn constellations that their grandparents couldn't see through the glow of industrial civilization. Earth's relationship with space transforms from competition to partnership. The planet provides life, beauty, and biological wisdom. Space provides materials, energy, and room for expansion. Neither world tries to be everything to humanity. Each contributes its unique gifts to the cosmic civilization taking shape. Scientists studying Earth's recovering ecosystems make discoveries that benefit space-dwelling communities. Understanding how natural cycles maintain themselves helps design better life support systems for asteroid cities. Earth's biological wisdom guides the development of space-based agriculture and ecosystem management. The blue marble floating in space becomes humanity's permanent reminder of what makes life precious. Not the materials that build civilization, but the consciousness that appreciates beauty, creates art, and finds meaning in existence. As you rest tonight, imagine Earth as it might become through this gentle transformation. A world where every mountain keeps its forests and every river runs clean. But this vision of Earth as sanctuary depends on more than just technology. Imagine a world where scarcity becomes a choice rather than a natural law. Where the phrase, "we can't afford it," loses its meaning because materials flow endlessly from space. Where poverty exists only in history books as a reminder of humanity's earlier struggles. This transformation begins quietly. The first asteroid mining missions return with small amounts of platinum and rare earth elements. Enough to make headlines but not enough to change daily life. Markets fluctuate as investors try to understand what unlimited resources might mean for traditional business models. But as the cosmic supply lines strengthen, something remarkable happens. The cost of materials that power modern civilization begins to fall. Not gradually, but in sudden drops that reshape entire industries overnight. Solar panels become so cheap that covering every roof makes economic sense. Electric car batteries cost less than the gas tank they replace. Countries that once fought over mineral rights become partners in cosmic ventures. When there's enough platinum for everyone, no nation needs to control the world's platinum mines. When rare earth elements flow freely from space, no region can hold the global economy hostage with export restrictions. Picture the geopolitical map redrawn by abundance rather than scarcity. Former mining nations transform into centers of manufacturing and technology. Countries rich in fossil fuels diversify into space-based industries. International cooperation flourishes when resources flow too abundantly for any single nation to monopolize. The economics of asteroid mining operate on principles that seem magical compared to earthly extraction. A single small asteroid contains more platinum than has ever been mined on Earth. The initial investment to reach it is enormous. But once harvesting begins, the returns continue for decades or centuries. Traditional economic models struggle to account for resources that are essentially infinite. When the supply of a material becomes unlimited, its price approaches zero. But this doesn't destroy wealth. Instead, it redistributes value toward creativity, knowledge, and human relationships. The things that can't be mined from asteroids become more precious. Your great-grandchildren will grow up in an economy where physical materials have little monetary value. Instead, they'll pay for experiences, education, and artistic creations. The design of a beautiful building will cost more than the materials to construct it. A compelling story will be worth more than the device that displays it. New types of businesses emerge to serve this post-scarcity economy. Companies that specialize in transforming abundant raw materials into useful products. Service organizations that help people navigate lives free from material want. Educational institutions that prepare minds for challenges beyond survival and accumulation. The banking system adapts to a world where traditional commodities lose their role as stores of value. Instead of gold reserves, financial institutions might hold intellectual property portfolios. Instead of mineral rights, investors might own shares in artistic endeavors or scientific research projects. Labor markets shift dramatically as manufacturing becomes almost entirely automated. Human workers focus on tasks that require creativity, empathy, and complex reasoning. Jobs emerge that previous generations couldn't imagine. Ecosystem designers for asteroid habitats. Cultural ambassadors between Earth and space communities. Experience architects who create meaningful activities for people with unlimited material resources. The transition creates temporary disruptions as old economic structures give way to new ones. Mining communities must reinvent themselves. Commodity traders learn new skills. Investment strategies that worked for centuries become obsolete almost overnight. But the overall trajectory points toward unprecedented prosperity. Poverty begins to disappear not through wealth redistribution but through wealth creation on a cosmic scale. When basic materials cost almost nothing, the essentials of life become affordable for everyone. Housing construction costs plummet when steel and aluminum flow freely from space. Clean energy becomes so cheap it's practically free. International development takes on new meaning when every country can access unlimited resources. The challenge shifts from finding materials to organizing human potential. Nations compete not for control of minds but for the most creative and educated populations. Brain power becomes the ultimate natural resource. Currency systems evolve to reflect the new reality. Money that once represented claims on scarce materials must find new foundations. Some economists propose time-based currencies where human attention and effort become the primary units of exchange. Others suggest reputation-based systems where trust and reliability create economic value. The stock market transforms as companies based on scarcity lose relevance while organizations focused on abundance flourish. Corporations that mine asteroids become immensely valuable initially but then see their worth stabilize as competition increases. Meanwhile, businesses that help humans thrive in post-scarcity conditions experience sustained growth. Consumer behavior changes fundamentally when acquisition stops being a primary concern. People focus less on owning things and more on experiencing beauty, learning skills, and building relationships. Material possessions become functional rather than status symbols. The phrase, "keeping up with the Joneses," loses meaning when everyone has access to the same abundant resources. Education systems prepare students for careers that don't yet exist. Children learn to think creatively about problems that have no precedent in human history. How do you maintain meaning and motivation when survival needs are effortlessly met? How do you structure society when everyone's material wants can be satisfied? The psychology of abundance requires adjustment. Humans evolved to hoard resources during times of scarcity. These instincts must adapt to reality where hoarding becomes pointless. Mental health professionals develop new approaches for helping people find purpose beyond accumulation and competition. Art and culture flourish in ways impossible under scarcity-based economics. When artists don't worry about affording materials or paying rent, they can focus entirely on creating beauty and meaning. Museums multiply as societies have unlimited resources to preserve and display human creativity. Music, literature, and visual arts enter golden ages sustained by cosmic abundance. Scientific research accelerates when budget constraints disappear. Experiments that would have been too expensive become routine. Space telescopes multiply as the materials to build them flow endlessly from asteroid mines. Research stations spread throughout the solar system as transportation costs approach zero. But this economic transformation, remarkable as it seems, must still overcome significant challenges. Yet even the most abundant resources cannot guarantee that humanity will use them wisely. Space doesn't forgive mistakes the way Earth does. There's no air to breathe if your life support fails. No rescue team can reach you quickly across millions of miles of void. Every decision carries weight measured not just in success or failure, but in survival itself. The first challenge is simply getting there. Asteroids drift at distances that humble the human imagination. The nearest valuable space rock might be farther from Earth than Mars. Journey times stretch across months or years. Spacecraft must carry everything they need for the entire mission with no possibility of resupply. Even small errors compound across these vast distances. A navigation mistake of just 1 degree sends a spacecraft thousands of miles off course. A tiny fuel leak that would be annoying on Earth becomes catastrophic when you're halfway to an asteroid. Engineers must design systems that work perfectly for years without any human maintenance. The radiation in space attacks everything electronic. Cosmic rays flip bits in computer memory. Solar storms can fry circuits in minutes. Spacecraft heading to asteroids must be built like armored fortresses. But armor adds weight. And every extra pound makes the journey more expensive and difficult. Asteroids themselves present unique puzzles. Unlike planets with predictable gravity and stable surfaces, asteroids tumble chaotically through space. Some spin so fast that landing on them would be like trying to step onto a spinning basketball. Others barely hold themselves together through gravity weaker than a soap bubble. Picture trying to anchor a spacecraft to a pile of loosely connected rocks. Touch the surface too hard and you might trigger an avalanche that buries your landing site. Drill too aggressively and you could split the entire asteroid apart. Every operation must be gentler than a whisper yet strong enough to extract meaningful quantities of materials. The extreme temperatures challenge every system. In direct sunlight, spacecraft components can heat to the temperature of boiling water. In shadow, they freeze colder than Antarctic winters. Materials expand and contract constantly. Seals crack. Metal parts warp. Instruments drift out of calibration. Communication delays test human patience and planning abilities. Radio signals between Earth and the asteroid belt take 20 minutes or more to make the round trip. Controllers on Earth can't provide real-time guidance to mining robots. Every spacecraft must be intelligent enough to make critical decisions independently. But perhaps the greatest challenge isn't technical. It's economic. The first asteroid mining missions will cost billions of dollars. Investors must wait years before seeing any return. Many early missions will fail completely. Learning to work in space requires expensive mistakes that teach crucial lessons for future success. The asteroid mining industry must bootstrap itself into existence. The first missions can only carry small, lightweight equipment. They'll extract tiny amounts of valuable materials. Just enough to fund slightly larger missions, which in turn enable bigger operations. Growth happens slowly over decades. International law struggles to keep pace with asteroid mining realities. Who owns an asteroid? What happens when two countries claim the same space rock? How do you enforce mining rights across millions of miles of empty space? Legal frameworks designed for earthly territories must evolve to govern cosmic resources. Safety protocols developed for Earth don't translate directly to space. Emergency procedures that work in gravity become useless in zero-G. Rescue operations that take hours on Earth might require months in space. Every mission ventures into an environment where small problems can quickly become life-threatening disasters. The human element adds complexity beyond pure engineering challenges. Astronauts working on asteroids will experience isolation more profound than any earthly explorer. Months away from human contact except for radio messages with 20-minute delays. The psychological stress could prove more dangerous than radiation or equipment failures. Space debris poses constant threats to mining operations. Tiny particles moving at incredible speeds can punch holes through spacecraft hulls. Larger chunks of rock and metal drift unpredictably through asteroid belts. Mining activities themselves create clouds of debris that endanger other operations. Weather in space takes forms unknown on Earth. Solar storms send waves of charged particles racing through the solar system. These cosmic hurricanes can disable satellites, overload power systems, and expose astronauts to dangerous radiation. Mining operations must shut down and take shelter during the worst storms. The engineering challenges multiply when you consider the scale of operations needed to make asteroid mining profitable. A single small mining robot might work for decades to extract enough platinum to justify its mission cost. Larger operations require enormous investments in equipment that must function perfectly across interplanetary distances. Quality control becomes crucial when replacement parts are years away. Every component must be tested more thoroughly than anything built for Earth use. Backup systems need backup systems. Manufacturing tolerances must be tighter than anything previously achieved. The cost of perfectionism gets multiplied by the impossibility of repairs. Yet each challenge overcome opens new possibilities. Learning to work reliably in space benefits every aspect of human technology. Materials science advances to meet space requirements improve products on Earth. Communication systems designed for interplanetary distances enhance global connectivity. The failures teach as much as the successes. Every mission that doesn't achieve its full goals provides data for improving the next attempt. Engineers study what went wrong and design better solutions. Each setback becomes a stepping stone toward eventual success. Some challenges create unexpected opportunities. The need for self-repairing spacecraft drives advances in artificial intelligence. Requirements for ultra-reliable life support systems lead to breakthroughs in recycling technology. The search for lightweight but strong materials revolutionizes manufacturing on Earth. International cooperation emerges from shared challenges. When everyone faces the same hostile environment, national boundaries matter less than human survival. Countries that compete on Earth find themselves naturally collaborating in space. The asteroid belt becomes a place where humanity works together against common challenges. The learning curve is steep but not impossible. Every problem has a solution waiting to be discovered. Human creativity has solved seemingly impossible challenges before. The same ingenuity that put humans on the moon will eventually make asteroid mining routine and profitable. Private companies and government agencies share the risks and rewards. No single organization has the resources to develop asteroid mining alone. Partnerships form naturally as different groups contribute their unique strengths. Competition drives innovation while cooperation shares the enormous costs. Insurance companies develop new models for covering risks that have never existed before. How do you calculate premiums for spacecraft that will operate for years without human oversight? What's the replacement value of a mining robot working on an asteroid millions of miles away? The first generation of asteroid miners will be pioneers in the truest sense. Venturing into territory where no human has ever worked. Solving problems that exist nowhere else in human experience. Their courage and determination will open the path for all who follow. But every challenge conquered brings humanity closer to a future where the resources of space transform life on Earth. The children who will harvest the first asteroid treasures are already walking among us. Some are sitting in classrooms tonight, learning mathematics that will guide spacecraft across millions of miles. Others are building robots in their garages, developing skills they'll someday use to create mechanical miners for space. They don't yet know their destinies among the stars. To them, asteroid mining still sounds like science fiction. But their young minds are already absorbing the knowledge and developing the creativity that will make cosmic abundance a reality. Picture a 7-year-old girl who loves to take apart old electronics. Her parents think she's just being destructive. But she's actually learning how circuits work. How electricity flows through tiny pathways. How sensors detect information and processors make decisions. These same principles will guide the robots she designs for asteroid exploration 20 years from now. Or imagine a boy who spends hours programming simple computer games. His friends think he's wasting time. But he's developing the logical thinking skills that will someday create artificial intelligence systems. Programs that can navigate the cosmic void and make split-second decisions millions of miles from human oversight. The future they're building starts with choices being made right now. Government officials deciding whether to fund space exploration. Investors choosing to support new technologies. Teachers inspiring students to pursue science and engineering. Each decision sends ripples toward a future where humanity reaches beyond Earth for its resources. Your own daily choices contribute to this cosmic transformation. When you choose products made with recycled materials, you support the mindset that will make asteroid mining profitable. When you encourage young people to study science, you help create the generation that will work among the stars. The timeline feels both impossibly long and surprisingly short. The first successful asteroid mining mission might not happen for 20 or 30 years. But that's less time than has passed since the first smartphones appeared. Less time than many of the trees in your neighborhood have been growing. Children born this year will graduate from college just as the first major asteroid mining operations begin. They'll enter careers that don't exist yet. Jobs with titles like zero-gravity manufacturing specialist or interplanetary supply chain coordinator or asteroid habitat designer. Their world will transform gradually at first, then all at once. Like watching a sunrise where darkness slowly gives way to light, then suddenly the sun breaks the horizon and everything changes. The first trickle of asteroid materials will grow into rivers of cosmic abundance that reshape civilization. These future citizens will face challenges we can barely imagine. How do you maintain human culture across the vast distances of space? How do you govern communities spread across multiple worlds? How do you preserve the meaning of human life when all material needs are easily satisfied? But they'll also inherit tools more powerful than any previous generation has possessed. Artificial intelligence that can solve problems too complex for human minds alone. Manufacturing technologies that can build almost anything from basic elements. Energy sources that never run out. The children of the asteroid age will think differently about limits and possibilities. They'll grow up knowing that scarcity is a choice rather than a natural law. That humanity's potential extends far beyond the boundaries of a single world. That cooperation across vast distances can accomplish what seemed impossible. Some will become the first permanent residents of space, living their entire lives in asteroid habitats or on mining stations orbiting distant rocks. They'll develop new forms of art and literature inspired by cosmic perspectives. Music composed for concert halls where sound behaves differently than on Earth. Others will remain on Earth but see their home planet transformed by cosmic abundance. They'll walk through forests restored by reduced mining pressure. They'll breathe cleaner air as manufacturing moves to space-based facilities. They'll inherit a world where environmental destruction becomes unnecessary. The transition between generations will tell the story of humanity's greatest adventure. Parents who grew up with scarcity will watch their children take abundance for granted. Grandparents who worried about running out of resources will see their grandchildren planning civilizations that span the solar system. Educational systems are already beginning to adapt to this future. Schools introduce robotics and space science at younger ages. Universities develop programs in asteroid geology and space-based manufacturing. The knowledge base that seemed like pure theory becomes practical preparation for cosmic careers. The dreams that inspire today's space exploration will become tomorrow's everyday reality. Children who watch rocket launches with wonder will someday commute to work on asteroid mining platforms. The International Space Station that seems like a miraculous achievement will appear primitive compared to the cities they'll build among the asteroids. Language itself will evolve to accommodate new realities. Words and phrases that don't exist yet will become common vocabulary. Children will learn to think in 3 dimensions because that's how space-based construction works. They'll understand orbital mechanics as naturally as current children understand traffic patterns. The mythology and storytelling of the asteroid age will reflect humanity's expanded perspective. Heroes won't just save individual communities but entire worlds. Adventures will span the solar system. Love stories will unfold across the vast distances between asteroid habitats and Earth. Social structures will adapt to communities scattered across millions of miles.